Okay, let's take a look at number 2 on page 207. You have a rotating toy above a baby's crib, and it makes one complete counterclockwise rotation or revolution in 1 minute. So we're going to look at A, B, and C. So let's start with A first. I'm going to switch you over to my notes. All right. So you have to remember that if we're counterclockwise, we're going to use positive 2 pi radians in our formula. So to get angular displacement, we have 3 revolutions in 3 minutes, and we're going to time those 3 revolutions by 2 pi radians. So some of you might be thinking, wait a minute, why are we using 3 revolutions? Let's look back at your book. And the problem says, what is the angular displacement in 3 minutes? Well, since it makes 1 revolution in 1 minute, it's going to make 3 revolutions in 3 minutes. So that's why I have in our problem 3 revolutions. So if we multiply that out, 3 revs times 2 pi rad, remember we drop the revolutions and just insert radians. And if you do 3 times 2 times pi, you come up with, I think it's 18.8, but it's roughly 19 radians. All right, that's that little children's toy. All right, let's move on to part B. So in part B, they want us to find the angular velocity in radians per minute. Well, good thing we did part A, and we have 19 radians. So our angular velocity formula is angular velocity equals our theta over time. So let's take a look at this. Since it makes 1 revolution in 1 minute, or 3 revolutions in 3 minutes, we can simply put 2 pi over 1 minute. You will get the exact same thing if you do 19 radians over 3 minutes, but I just simplified it for you. So let's solve this. Since our displacement is 2 pi radians over 1 minute, that's all you do is 2 times pi divided by 1. And this will give you an angular velocity of 6.28 radians per minute. And again, if you want to know, all right, well, tell me again how you did that. The book is asking us, let me find that. What is the toy's angular velocity in radians per minute? Well, we know that it makes 1 revolution in 1 minute. So that's simple. That's why we do 2 pi, because back to your original notes, 1 revolution is 2 pi. And over how many minutes? They said 1. So that's where we get the 6.28 radians per minute. You want to try part C? I'm sure you do. So part C says, the toy is turned off. Does it have a positive or negative angular acceleration? Well, it's already going in a positive direction, correct? Yes. If it is slowing down, remember as you slow down, you decelerate, which means you have a negative acceleration. So even though it's slowing down in a positive direction, the acceleration itself is negative. And I think we're going to stop there for today. What I'd like for you to do is try number 3 by yourself. So number 3 is if a truck has a linear acceleration of 1.8 meters per second squared, so you remember what acceleration is. It's the change in velocity over the change in time. And the wheels have an angular acceleration of 5.2 radians per second squared. You know what? You are not going to do number 3 by yourself. I will make another video to help you with number 3 because this is certainly not something that you have done on your own yet. But we are going to find the diameter of the truck's wheels. Give me a second to set up notes for you, and I'll be right back. Okay, let's try that again. So obviously, number 3 is not something you could do on yourself yet. So let's do it together. If a truck has a linear acceleration of 1.85 meters per second squared, and the wheels have an angular acceleration of 5.3 radians per second squared, what is the diameter of the truck's wheels? Well, first of all, you have to know what the relationship is between linear acceleration and angular acceleration. So let me show you that. So first of all, I just wrote down the information that was given to us because, in physics, that's what you do. So our linear acceleration is here. Our angular acceleration, the one that looks kind of like a Jesus fish, is right here. And now we have to find the diameter. So what's the relationship? Well, obviously I messed up the first time. The formula for the relationship is linear acceleration is equal to angular acceleration times the radius. Well, good. We have enough information now to solve this problem. We can rearrange to solve for the radius like this. The radius will equal linear acceleration over angular acceleration. Now, let's go ahead and insert our numbers, which I already did for you. So, sorry about that. If you look up here, we have our linear acceleration right here, which is 1.85 meters per second squared. And we have our angular, which is 5.23 radians per second squared. So if we calculate those numbers, you're going to come out with 0.354 meters. Now you're probably looking at that thinking, wait a minute. What just happened to the radians? Well, the seconds per squared, I'm sure you can see that they cancel out. Meters, though, well, radians can just disappear once we switch to meters. I will say that again. Radians can just disappear once we switch to meters. I know physics is a weirdo, but it's true. Radians, and I think I mentioned this a while back, you'll see that radians can just kind of come and go. They're not like a hard unit that always has to be canceled out. It is one that can kind of come and go. All right, so now we have the radius. How do we get diameter? Anyone? Yay! Right, 2 times the radius is going to give you the diameter. So our diameter is 2 times 0.354 meters, which will give us 0.708 meters. And then that is how you do number 4. Any questions? I'm going to have you do one more by yourself today. And, sorry guys, I'm going to have you do number 4 on your own. And so you're going to take the truck in the previous problem, the one we just did, and the truck is towing a trailer with wheels that have a diameter of 48 centimeters. So you're going to have to switch that over to meters to match what we had here. So in this problem, if our diameter is 0.708 meters, the diameter of this truck, of the towing trailer, is going to be 0.48 meters. Okay, so don't forget to convert that. So now you're going to compare the linear acceleration of the trailer compared with that of the truck. So you're going to have to find that. So I showed you how to get linear acceleration here. And if you have questions, please look over here at linear and angular measurements. They'll give you the relationship. The relationship is the formula for solving these things. If you have questions, please let me know. And I promise we will get through this month or a couple of weeks the best we can. Thanks. Have a good day.